Today we're going to be talking about adding and subtracting polynomials, and I'm going to apologize in advance because we've got lots of notes to write down, but we'll make up for that by not having to do very many example problems. There's some definitions that we need to be aware of. The first one is the monomial, and a monomial is an expression that's a number, a variable, or a product of a number and one or more variables. So some of our examples that we have are the number 12. 12 is a monomial. The variable y is considered a monomial. The product negative 5x squared y is what we call a monomial. And c divided by 3 can also be considered a monomial. So this is just sort of some of the things that we're looking at today. When they talk about the degree of a monomial, they're talking about the sum of the exponents of a monomial's variables. So you look at the variables, you add up their exponents, and that will be the answer for the degree of the monomial. Let's take a look at example 1a. For the degree of 2/3 x, we look at the variables. We have an x here, and x has a 1 for an exponent. So the degree of this monomial would be 1. Pretty simple. B example, we have x squared and we have y cubed. We're supposed to take the sum of these exponents, so we would say 2 plus 3, and this degree is 5. For the example C, we have negative 4. Negative 4 has no variables, and so since there are no variables, that would mean that its degree is just 0. Let's look at our next definition. We have what's called a polynomial, which is just a group of monomials that we've added and subtracted together. So it is the sum or the difference of two or more monomials. So the examples we just looked at, we can add and subtract those, put them together, and that's what we call a polynomial. And you can see here we have 3x squared plus 2x minus 1. Here's a good example of what a polynomial will look like. We say that polynomials are in standard form of a polynomial when the monomials are in order from greatest to least degree. So we're kind of keeping them in an order where we list the monomial that has the highest degree first, and we work our way down until we get to the monomial with the smallest degree. And the degree of a polynomial is going to be the degree of its largest monomial degree. So if we take a look at this example that we have right here, 3x squared plus 2x minus 1, there are 3 monomials in this term. The 3x squared has a degree of 2. The 2x squared has a degree of 1. The 1 has a degree of 0. And so we would say that this polynomial has a degree of 2 because the monomial that is the largest in this polynomial is 3x squared, and its degree is 2. So this polynomial's degree would also be 2. And we have rules for naming them. There are 2 ways to name a polynomial. One of the ways is by using its degree, and if we have a polynomial that is degree of 1, that's what we call linear, when it's just x to the first. Quadratic is when we have a degree that's second, so this would be like our example in green here. This would be a quadratic polynomial because we have our exponent of 2 here is the highest. A cubic would be a degree of 3. Fourth degree would be degree of 4. We have 5th degree, 6th degree. That just goes on and on like that. The second way to name it is using the number of terms. Binomial means that there are 2 monomials. A trinomial, you can see by the tri here, that's going to be 3 monomials. So our example in green, we have 1, 2, 3. So this is a trinomial. Quadnomial would be a 4. You have a quintinomial, and so on and so forth. And so if we were going to name our example in green by its degree and its number of terms, we would call this one a quadratic trinomial. That would be its name. That's probably the craziest part about our notes today. So that pretty much takes care of all of our definitions we've got to talk about. And let's talk about what we're going to be doing with these polynomials. Today we're going to be adding and subtracting them, and there's a couple rules to remember when we add and subtract polynomials. The first one is that we are only adding and subtracting the coefficients. So the variables we're not really concerned about apart from just figuring out what is like terms. And that leads us to our second rule. We are supposed to leave all of the exponents alone. We are not going to be multiplying or adding exponents together. We're just going to leave those alone. So let's take a look at our first example here. We have the polynomial 4x squared plus 6x plus 7 plus 2x squared minus 9x plus 1. The first thing we're going to do is circle our like terms. So I can see that we have an x squared here, and we have a 6x and a negative 9x, and we also have a 7 and a 1. And all we have to do is just add these together. So let me put my x squares together first, since those are the highest degree. We're doing 4x plus 2x. We add the coefficients according to our first rule. So 4 plus 2 would be 6. And x squared, the second rule says, leave exponents alone. So all we have to do is write down x squared beside our 6. And we move on to the next highest degree. The next highest degree would be our x terms. 6 minus 9. That is negative 3. And we leave the exponents alone, so it's just an x. The last degree is the degree of 0 with our constants. We have 7 plus 1. 7 plus 1 is 8. It's in standard form because our highest degree monomial is listed first, and it goes in order from greatest to least, and we are done with this. This is going to be our answer for today. We can't do anything else with it. We've added what we could, we subtracted what we could, and now we're just leaving it alone. Our next example is going to be different because this time we're subtracting, and there is a rule change that we have to remember when subtracting, and it all has to do with the subtraction sign. When you subtract, this is going to change the sign of everything behind it. So our first polynomial is going to stay the same, and I'm going to write that down again. But this minus sign changes the signs of everything else behind it. So instead of writing down a plus x cubed, we're going to write down minus x cubed. Instead of writing down minus 8x squared, we're going to write down plus 8x squared. And we'll do the opposite here, and that will be minus 11. So if you want to draw an arrow to your minus sign or circle it or go ahead and change the signs of everything behind it, you can, but you cannot forget that simple step. Let's go ahead and put together our like terms. We do have a cubed monomial here and here. We have a squared, and we have an x to the first and an 11, but those aren't like terms, so we're not going to worry about those just yet. Let's put together our x cubes. We have 2x cubed minus x cubed. That would be 1x cubed. We have 5x squared plus 8x squared. That's 13x squared. Now we have a negative 3x with nothing to combine it with, so it's just going to drop down. And my negative 11 here has nothing to combine with, so it's also going to drop down. And I check it again. It's in standard form. We've got degree from highest to lowest, and there's nothing else we can do for like terms to combine, so we have our answer. And that will conclude our video for today.